Now for 4, we have two inequalities connected by the disjunction OR. So to be a solution, a value does not have to satisfy both of these inequalities. It can satisfy one or the other. So starting at the left, we'll isolate negative 5x, and to do that we'll add 8 to each interval, and we get 8 plus 12 is 20. Or isolating negative 5x and adding 8 to each interval, negative 3 plus 8 is 5. Now to isolate x, we'll divide each interval by negative 5, and we'll thus have to flip the inequality because we're dividing through by a negative, and 20 divided by a negative 5 is negative 4. Or, and isolating x by dividing by a negative 5, we'll have to flip the inequality, and 5 divided by negative 5 is negative 1. Graphing that, we have a hash mark at negative 4 and another one at negative 1. There's no equal sign associated with that inequality, so we have a parenthesis, and x is any value less than negative 4. At x is greater than or equal to negative 1, at negative 1 we'll put a bracket because there's an equal sign associated with that, and shade everything to the right. And now, any value in this interval or in this interval will satisfy the given compound inequality. So in set builder notation, we have the set x such that x is less than negative 4 or x is greater than or equal to negative 1. In interval notation, we have parenthesis negative infinity, comma, negative 4 parenthesis, union, which corresponds to the word or, bracket, negative 1, infinity, parenthesis. Well, for 5, we have another disjunction. So, because there's our word or, and let's resolve each of these inequalities and see what we come up with. So the first step on the left is to isolate the term with x in it, so 3/4 x, and now we'll subtract 5 from both sides, and negative 5 minus 1 is negative 6. Or, again, we have to isolate 3/4 x and move that 5 to the other side, so we'll subtract 5 from both sides, and 8 minus 5 is 3. Next step, we must isolate the x, so we'll multiply both sides by the reciprocal of 3/4, which is 4/3. So 4/3 times 3/4 x is less than negative 6 times 4/3. Or, and doing the same thing over here, we have 4/3 times 3/4 x is less than 3 times 4/3. Now in this case, the product of reciprocals is 1, so we get x. On the right, 3 goes into negative 6 negative 2 times, and negative 2 times 4 is negative 8. Or, the product of reciprocals is 1, so we get 1 times x is x, and here the 3's divide out, and we have x is less than 4. So on a number line, we've got a hash mark at negative 8, and no equal sign associated with this inequality, so we'll put a parenthesis and graph everything to the left of 8. Relative to 4, we'll put another hash mark and put a parenthesis, and we'll graph everything to the left of 4. Well, notice, once we get past negative 8, we've picked up all of these values to the left of negative 8 too. So then all our solutions lie, since it's a disjunction, only one of these inequalities has to be satisfied to satisfy the compound inequalities. So the solution then is x such that x is less than 4, and in interval notation that would be negative infinity, a parenthesis before that, and 4, and close with a parenthesis. For our final inequality, we have another disjunction, the word or. So we'll start working left to right, and our first task is to isolate the term with x in it. So subtracting 5 from both sides, we have, let's see, negative 3x is greater than or equal to, and 11 minus 5 is 6. Or, again, subtracting 5 from both sides, we have negative 3x is less than, and 17 minus 5 is 12. Now, isolating x, we'll divide both sides by negative 3, and dividing by a negative, to accommodate that, we have to flip the inequality, and 6 divided by negative 3 is negative 2. Or, again, dividing by negative 3 and flipping the inequality, 12 divided by negative 3 is negative 4. Now to graph, we have a hash mark at negative 4, and since there's no equal sign associated with that, we'll put a parenthesis and graph everything to the right. X is greater than that. Now we have another hash mark at negative 2, and there's an equal sign associated with this, so we'll put a bracket and graph everything to the left. And notice we've graphed the entire number line. For a value to satisfy this compound inequality, it just has to satisfy either this inequality or that. And so any point in the number line will satisfy this compound inequality. And so the solutions in set builder notation are the set x such that x is any real number. In interval notation, parenthesis, negative infinity to infinity, and we are done.